Hello and welcome, ladies and gentlemen. We are in Module 1, Topic 2, Packet 2. We are going to be on this getting started exercise here. Cattywampus. What a word. If you don't know what it is, Google it. It's pretty fantastic. Anyway, so here we go. We have this paragraph. I'll go ahead and read it. A quadrilateral may be convex or concave. The quadrilaterals you are most familiar with. Trapezoids, parallelograms, rectangles, rhombi, and squares are convex. Okay, so convex, and then we have a little example right here. For a polygon to be convex, it contains all of the line segments connecting any pair of points. It is concave if and only if at least one pair of its interior angles is greater than 180 degrees. So, excuse me, it is concave if and only if at least one pair of its interior angles is greater than 180 degrees. So that is our definition for a concave quadrilateral versus a convex quadrilateral. Now we have this. Consider the two quadrilateral. Wow, I cannot read. Consider the two quadrilaterals shown. A quadrilateral has exactly two diagonals. I'm trying to find my straight edge really fast. I must have thrown it on the ground or something. Here it is. There we go. So number one says draw the diagonals in the two quadrilaterals shown. What do you notice? So if you'll remember diagonals, okay, if I were to have, say we had, so just kind of over here on the side, say I had a square. If I asked you to draw the diagonals of the square, you would pretty easily go like this. Because these are actually diagonal, right? So if this is up, this is sideways, diagonal, right? These are actually diagonal. Basically, so what diagonals are, though, in quadrilaterals is just connecting opposite corners. So if you think about my corners or my points, okay, if you think about them like this, and then you're just connecting the dots on ones that are opposite each other. So right here, okay, and then right there, and then on this one, okay, so same thing. If I have my points, this one gets a little more tricky and confuses some people, but it's still not that bad, I promise. Okay, if I'm just connecting my points here that are opposite one another, these two are pretty easy to see that these ones are opposite. So I can connect those. And then here on the top one, these are technically opposite, and I do want to connect them even though they're going to go outside of the shape. Okay, so we'll go ahead and do that. There you go. So now I have this kind of like triangle looking shape with my two diagonals. This top one's a diagonal, this bottom one's a diagonal, and then in this convex shape, these two are the diagonals. So draw the two diagonals in the two quadrilaterals shown. What do you notice? Okay, so quick thing. I've talked about this in class before. What do you notice? These are my favorite questions, and I'll tell you why. Because there's not just one right answer. Okay, I love math because there's one correct answer most of the time. But what I don't like about math, one thing that I despise about math, okay, is that people will tell you there's one way to get to the right answer, okay? And so here, literally, this is an open-ended question. It just says, what do you notice? You can notice anything about these, okay? I'm going to go ahead and tell you what I notice, and I'm kind of a cheater because I know exactly what Carnegie wants you to notice. Carnegie being the people who come up with these lessons, right? Cattywampus, the people who print that, okay? So I'm a cheater because I know what they want, so I'm going to go ahead and tell you what they want. But please, if you notice something that's different from what Carnegie has, I would ask you very kindly to please write that down as well if there's something that you notice, okay? So here's what I notice about the diagonals here. In the convex shape, so I'm going to go ahead and go convex, okay? In the convex shape, both diagonals are inside the shape. Okay, and then for number two, or sorry, so that was for the convex shape, and then for the concave shape, what I notice is that one diagonal is outside the shape. Okay, and that one, you know, if you draw your quadrilaterals, that's not too hard to see, right? Because both of our convex, or if you draw your diagonals, that's not too hard to see, right? Our convex ones, they are contained within our original shape, which was this quadrilateral here. For the concave, our original quadrilateral was this kind of boomerang-looking shape, okay? And our diagonals, we have one outside and one on the inside there. So that one's not too bad, okay? Now, number 2, okay, we're going to make a conjecture about the diagonals of a convex quadrilateral and about the diagonals of a concave quadrilateral. So we need to make 2 different conjectures, one for convex, one for concave. Okay, and the best way that I think that you would do this, the best way that I would think about trying to make a conjecture for these things is I would say go ahead and work off of what you just noticed up here. So if you put that you noticed something about the convex, so I put that both diagonals are on the inside of the shape, and then for concave I put one diagonal is outside the shape. Okay, if you put the same thing as me, work off of this to create your conjecture. If you wrote something different, say, I'm trying to think of another one now. My brain got so one-track mind, I can't think of another one. But if you got another something that you noticed on this convex shape, go ahead and work off of that for your conjecture, right? So an example, so mine says both diagonals are inside the shape. So then my conjecture for convex quadrilaterals would be that all diagonals, and I can't spell, diagonals, there we go, are inside convex quads. Okay, so my conjecture, my assumption would be that the diagonals of convex quadrilaterals are always inside the shape. So all diagonals are inside convex quadrilaterals. And then my conjecture for 2, so in here I said one diagonal is outside, so that means that there's one inside, right? Because for a 4-sided shape, there's 4 corners. And if I connect opposite corners there, that means that I'm going to have 2 diagonals. So that if one is on the outside, that means one is on the inside. So for concave, I would say one diagonal, there we go, is always inside a concave quad. One is always on the outside. There we go. Sorry, I got a little smashed there. Here we go. Okay, so like I said, when you notice something, take what you notice, turn it into a conjecture. It's not that hard. Just so both diagonals are on the inside, that can go ahead and be your conjecture. All you have to do is change the wording on it a little bit, right? You notice that both the diagonals are on the inside, so then your conjecture, your assumption would be that diagonals are always on the inside of convex quads, or that all diagonals are inside convex quads, right? So same thing with the concave, one diagonal is outside, that means one diagonal is inside, so just changing my language a little bit, one diagonal is always inside of a concave quad, and one is always on the outside, okay? So here we go. So it says the diagonals of any convex quadrilateral create 2 pairs of vertical angles and 4 linear pairs of angles. Okay, so just a real quick reminder for you. Okay, vertical angles are angles that intersect. Okay, and vertical angles are the ones that are opposite each other, and they have equal angle measures. So if this was angle X, if this angle measure was X, this angle measure would also be X. If this angle measure was Y, this one would also be Y. They're matching, right? They're paired up. They're vertical pairs, okay? And then a linear pair of angles is if you have a line, just a single line, and then I have an angle that's created off of that line, okay? The pair here, I won't use X and Y again. We'll go ahead and go A and B. So A and B are considered a linear pair because when you add them together, they create a line, and the angle measure of a line is 180 degrees. So any 2 angles that add up to 180 degrees, okay? So say this was, it's obviously more than 90. Say this was 120 and this was 60. 120 plus 60 would add up to 180. That would be, A and B would be a linear pair. So what we were saying is that convex quads have 2 pairs of vertical angles and 2 pairs of, or 4 linear pairs, okay? So now I'm going to look at number 3. It says label the vertices of the convex quadrilateral as well as the point of intersection of the diagonals. Identify each pair of vertical angles in each linear pair. So I can label this however I'd like. I'm just going to go A, B, C, D, and then I'm also need to label the intersection, so I'm going to go E, okay? And now I need to tell which of these angles are vertical angles, so which ones are the vertical angle pairs, and which ones are the linear pairs. So over here, I'm going to go vertical angles, okay? So for vertical angles, we said that ones that are opposite have equal angle measure. Okay, so it looks like AED, so angle, and then I'm just down here writing, and I'll show it in a second. Angle AED is congruent to angle BEC, right? And then I wrote it down here. just like that, under vertical angles. So that was this one and this one. So bottom left and top right, they're opposite each other. Okay, and now we can go top left with bottom right. So that'd be AEB and DEC. Okay, now those angles are equal to each other. So those are, we said, for us to write the vertical angles and each linear pair. And this said that there were 2 pairs of vertical angles, so I have 2 pairs of vertical angles, so we're good there. So now I'm going to have linear pairs. Okay, so now I need linear pairs. So I need every combination of 2 angles that add up to 180 degrees. Well, I have 2 lines here. I have line AC and I have line BD. Those are my 2 diagonals. So line AC, if you want to think of it this way, okay, so just kind of side note over here, right? Just kind of over here on the edge. A line, we said the angle measure of a line is 180 degrees. Okay, well, it's 180 on the top, and then it's also 180 on the bottom. So, okay, so this does not mean that the angle measure of a line is 360. That's not what that means. It means that the top part, 180, okay? If you measure it from this line, the left part of the line, to the right part, that's 180. Or if you were to measure it from the right part underneath to the left part, like this, that's also 180. So if you want to think of it like this, AC has 2 parts, or 2 pairs that it creates. We need the top pair that create the 180 on top, and then the bottom pair that create the 180 degrees on the bottom. So on the top, I'd have AEB and BEC that create line AC right here. So I'd go AEB and BEC. And those are not equal. With vertical angles, they're congruent. With these ones, they are not congruent, so I put equals there. That's a mistake. Okay, these are just linear pairs. So AEB, BEC, so that's the top part of line AC. Now for the bottom part of AC, I have AED and DEC. AED and DEC. Okay, so there's two linear pairs. Now I need 2 more. Okay, so now if I look at line BD, this diagonal, same thing. So over here, my line, I said that it has a top 180 and a bottom 180. If my line is up and down, it has a left 180 and a right 180. Okay, so now if I want to do the left 180 of this BD, it would look like it'd be BEA and AED. So BEA, when I'm off the screen still, BEA and AED. That's another pair. And then the last one, so that was the left side. BEA and AED was the left side of this line BD. So now for the right side, I'd go BEC and CED. So I kind of ran out of room here, so I'm just going to go BEC and CED. So pairs, K, would be here's a pair, here's a pair, here's a pair, and then our last pair right there. Okay, so there's our 4 pairs, which lines up with what this says, that convex quadrilaterals create 4 linear pairs of angles. So that is your getting started. I hope you all have a wonderful evening. I will see you all in class. Yeah, I hope you guys have a great one. Ask me any questions if you need them in person. Okay, hope you have a great one. Adios.